Hey, year nines. Sadly, this is the second time I've tried to record this video because the first time I recorded it on mute. And I'm sure that sounds amazing, but it's kind of frustrating for me. So, inequalities. I hope that you are able to do the quizzes, and I hope that you are able to recall what these symbols all mean. So, greater than, less than, or greater than and equal to, and less than and equal to signs are all kind of the different signs. How you read them depends on where they're placed. So, if you had this would be 4 is greater than 3, and the mouth should always point. So the mouth should always point in the direction of a larger number. So that would be a true statement. So if you saw that, you would say that that is a true statement, and that would be totally acceptable. So if you ever saw somebody say that, you would say that that is true. It's possible to make these a false statement. If I said that something like this, if I had negative 3 is greater than 7. Yikes, that's false. That's a false statement. And we're going to try to keep things to mostly true statements today. Another example of a statement that you probably saw in your practice room quizzes is you can also make these you can include some operations in here. So negative 3 times negative 5, is it greater than or equal to 15? Well, negative 3 times negative 5 is positive 15, and so that is a true statement because negative 3 times negative 5 is 15, and because we have the or equal to statement line, that means that this is a true statement. So we're just looking at comparisons, and those are a couple different comparisons. And we can also apply these as well. So let's imagine that we've got a pool, and the town has said that the rules around having a pool is that the perimeter of your pool must be less than 50 meters. All right. And your yard, well, you can fit your pool to have a 12-meter side. What that now means is you can have this side here be any length that you want. It can be an unknown amount of meters. And that unknown amount of meters we can use to represent it with greater than less than symbols. So we know that this side would also be 12 meters as well. So knowing that they're both 12 meters, you know that they would combine to be a total of 24 meters. Sorry, I'm just up near the top. If you then try to figure out how many meters you got left after this, well, you could take your 50 total meters, you could subtract your 24 meters, and note that the remaining perimeter for these two sides, you've got 26 meters of length. Now, if you think about it in your head, you know that you can take 26 divided by 2, and one possible length for these sides could be 13 meters. But that's the maximum amount of space or area perimeter that your pool could be. So for two sides were 13, that all add up to be 50. But don't forget that the town said it has to be less than, so we probably can't use 13. Well, could you use 12? Yep, you could. You could also make yourself a skinny pool. I'll just try to draw this in. I'm going to erase that one little 12 here, just give myself a little bit more room. You can make yourself an itty-bitty lap pool. A little itty-bitty lap pool. Keep that one side to be 12 meters still. And you make that be 1 meter, and that still would be within the rules, because then it'd be 12 plus 12 is 24, plus 1 gets us to 26 meters. We could even shrink it down a little bit further, and you could probably get it to be half a meter or a third of a meter, but you probably could never have it to be equal to 24 meters. So your other thing that you know from this information is that your perimeter will always be greater than 24 meters. So that's kind of a way of thinking about these problems as well. To kind of build some skill, to review a couple things, you can take comparisons. If I gave you x is greater than 1, we can represent this with the number line. So just a reminder, there's your number line right there. When you'll be doing this, I'll have number lines for you just so that you don't have to draw them, but try to keep your ticks nice and evenly spaced. I'll try my best. I'll make sure to label your ticks. 3, and negative 4. Okay, so for this first one, I'll just grab my pen. So first thing we know is that we're located at 1. So we're looking at 1 to start. So we'll draw a circle at 1. Next thing we need to figure out is this an open circle or a filled in circle. And if it's just a greater than or less than symbol, then you keep it as an open circle. If it was a greater than or equal to, less than or equal to, you would fill that circle in. And I'll show you examples of this. Because x is greater than 1, you're now going to draw an arrow, and that arrow is going to extend all the way to positive infinity. Instead of having to draw it all the way to positive infinity, you just draw it to the end of your number line, include an arrowhead on the end of it, so that way you know that it extends all the way forever to positive infinity. So there's how you would represent x is greater than 1 with a number line. Another example would be this one, x is less than or equal to 2. All right, so let's get our number line set up. 2, 3, 4, -1, -2, -3, and -4. So again, I'm going to start by looking. Where do we start? We start at 2, so I'll draw my circle. The next thing we look at is this a greater than, less than symbol, or is this a greater than, equal to, less than, equal to symbol? Well, it's a, in this situation, you'd read it as x is less than or equal to, and there's your or equal to 2. So we would then fill in our circle. There we go. It's now a filled in circle to show that 2 is included as a possible number. And now we draw our arrow, and because x is less than 2, we extend this arrow all the way to the end of a number line. We include an arrowhead to show it extends to all numbers all the way to negative infinity. So x can be 2, 1, 0, -1, -2, -3, blah, 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 all the way to negative infinity. So that's another way of looking at that. Now, sometimes you might get a situation, and I'll give you a quick example here. This one's going to be a little crazy. If I gave you x is greater than -2, and x is also less than or equal to 3. You can have 2 together at the same time. So one thing you might think in your head is you're like, oh, number line. So you know that x 0, 1, 2, 3, -1, -2, -3. So you know that x for the first piece of information is greater than -2. So there's -2 right there. I draw an open circle because it's just greater than, and because it's x is greater than -2, I can draw my arrow going all the way to infinity. And then also at the same time, x is also 0, 1, 2, 3, -1, -2, -3. X is also, there's 3 in my number line. Because it's also equal to, I draw as a filled in circle, and then I draw that extending all the way to negative infinity. But in reality, this is actually a combination. This inequality has these things called bounds. And we have a lower bound and a upper bound to ours, and we need to actually combine these two together. We need to put them together. So when we put them together, I'll just rewrite what I had there. It's -2. X is greater than -2 and less than 3, I believe, and equal to was the original one I had. So what we're going to do now is I draw one number line. I'm going to express this whole thing with bounds on one number line. 0, 1, 2, 3, -4. Oh, why did I draw -4? What was I thinking? It's just 4. Let's see if I can just erase that negative. There we go. Perfect. Just 4. And this is -1, -2, -3, and -4. Perfect. So the first thing we're going to do is we're going to look at we'll look at 3 first. Just feel extra on there, so I'll draw my circle. Is it a filled in or open circle? Well, it's equal to, so I fill it in. So then we'll look at, that's our upper bound done. Now we'll look at our lower bound. We'll again draw a circle at -2. And then we keep it as an open circle because it's just a greater than less than symbol. And then finally we show that this value is anything between, it's any number greater than -2, so it could be -1, 0, 1, 2, and it could be 3, or and it could be 3 because it's equal to 3. So there is a number line to show that value, and we could call it has an upper and a lower bound to the possible answer that we have. The other crazy thing that we can do is we can also have these represent, we can give you a word situation and then you could then represent it. So if I gave you that x is greater than -2, but less than or equal to less than or equal to 3. The first thing we can do is we can represent that. So first write x. X is greater than, so x is greater than -2. I wrote my lower bound first. Next I look at my upper bound, the larger number, and it's less than or equal to 3. So there's my upper limit. I can draw my number line to represent this. 0, 1, 2, 3, 4. Sorry if my 3 is messy. -1, -2, -3, -4. Fantastic. So we'll start with our lower bound this time. So it's -2. Open circle because it's just a greater than less than symbol. Next I go to 3, and because it's greater than or equal to, less than or equal to symbol, I fill it in. I draw my line, and I have represented x is greater than -2, so it's greater than -2, but less than or equal to 3. So there's all the range of answers that this could possibly be. I hope this helps you understand how to represent inequalities using a number line to begin. We'll expand on this more tomorrow, but for now, that's a good place to start. Good luck on your practice, and make sure you're reaching out to me if you're having any questions, and I'll try my hardest to be responding. Take care, and goodbye.